These could equally be written with pi over 2 instead of 90 degrees. What that means is that the sine of 30 degrees is equal to the cosine of 60 degrees. Is that true? Yeah. So that's what these identities mean. So they're cofunction identities. It comes from those triangles. The other angle in a right triangle gives you the complementary angle. So that's where these come from. So they are on your trick helper. If you don't want to write them down, I don't blame you. Everyone see them on your trick helper? Look under cofunction identity. Bottom right. See? So it's the exact same thing, except they used pi over 2, I used 90. Those are equivalent identities. So, how do we use these things? These, mainly we're going to be working with the sum and difference identities. We'll look a little bit at cofunction identities. So find the exact value of the cosine of negative 75 degrees. Go. I gotta pause for a minute there. Why? It's not a unit circle question, right? So up until this point, if it was not a 30, 60, 90 or a 45, 45, 90 triangle, I couldn't do it. So one of the identities is going to help me find the cosine of negative 75. Now one thing I might do just to simplify my life is go, well, cosine of negative 75 is equal to cosine of positive 75. You wouldn't have to make that change. We could work with it either way, but it is nice to know. How does she know that? The negative angle identities or the even odd identities. So I want to use the cosine sum identity. So I want to think of two angles that I know that are on the unit circle that add to give me 75. 30 and 45. Okay? So I could write this as cosine of 30 plus 45. Okay? And then what does that equal using the identity you wrote down today? Does everyone see where she's getting that information? Everyone see that? Can I now find all these values? What's the cosine of 30?
Square root of 3 over 2.
Where is he getting that information? He said from the unit circle he has memorized, right? Because we were getting really good at that unit circle by now, right? What about the cosine of 45?
Square root of 2 over 2.
What about the sine of 45? And so simplifying this, you can multiply. They're both under a radical, so I get the square root of 6 minus the square root of 2 all over. Any questions so far? And that is a number, isn't it? It looks flippy, but it's just a number, and it's the exact value of the cosine of 75 degrees. So something that was not on the unit circle, we now were able to find that value. Always weirds people out when we have over 12s or radians in general. But it turns out that they're not that bad. What we really have to think of is simplification of fractions. Over 12, if the numerator was what numbers, would it simplify to something I could work with? Right? If it's 2, because then I get a 6 on the bottom, or any even number, why is a 6 on bottom good? That's a 30-degree angle, so that's one I can use. Or 4 options? Does it matter which option you choose?
No.
No, it makes no difference at all. 8 and 9 sounds good to me, but could have been anything. And it doesn't matter which one you pick. There's no right answer on that. As long as you pick a combination that does reduce. And so I'm going to reduce them before I rewrite. So I get cosine of 2 pi over 3. And so that's good news. Those are both values I can deal with. So I have cosine of 2 pi over 3, cosine of 3 pi over 4, minus sine. What am I doing right now? Yeah, I'm using that identity. Cosine of 2 pi over 3. First of all, what kind of reference angle is it? It's a 60. What did you tell me cosine of 60 degrees was earlier? You told me it was a half, right? So wouldn't it still be a half? We just needed to decide if it's positive or negative.
Yeah.
And what quadrant is 2 pi over 3 in? The second quadrant, and cosine is? We're getting better at the unit circle, right? There's really only 3 values you need to memorize, and then you can just decide what quadrant you're in. Cosine of 3 pi over 4. And we know over 4 is going to be a radical 2 over 2, and again, 3 pi over 4 is in the second quadrant, so it is negative. Sine of 2 pi over 3, sine is positive in the second quadrant, isn't it? So what's sine of a 60-degree angle? And what is sine of a, and it is positive, again, because we are in the second quadrant. Parentheses there, but okay. Positive radical 2 over 4 minus radical 6 over 4. Any questions about that one? It does. Looks awful. In fact, it doesn't seem. Looks pretty good. Maybe I can't do it. Does it look like an identity to you?
Yes. But
Which identity does it look like? Cosine of an angle, cosine of another angle, plus sine of an angle, sine of another angle. Cosine A minus C? Yeah? Almost. What is the cosine of that?
Zero.
Because it's value, the x value on the y-axis is 0. What? Looks pretty nasty, isn't it? Okay, so another question. Suppose that cosine of s is 15 over 17, and sine of t is negative 24 over 25. So that's a t or in quadrant 4. Find cosine of s minus t. It is a big time rarity, like once in a lifetime, but I have seen this show up on an ACT before. Not necessarily with this problem, but with what's like with a difference. I did some or different identity. I did not mean to use cosine all day long. I seem to have used cosine all day long with the examples I picked. This works identical if it's a sine identity. You just use the correct identity, and so same stuff. Just use the appropriate identity. So if I want to find cosine of s minus t, do you agree that that's cosine of s, cosine of t, plus sine of s times sine of t? Can I find the cosine and sine of s and t? If I know what quadrant you're in? I already already know the cosine of S and I already know the sine of T. I just need the sine of S and the cosine of T. Does that make sense? How would I find such a thing? You have options. Probably the easiest way is to draw a
Triangle.
triangle in quadrant 4. Two different triangles in quadrant 4. I'll call this one S and this one T. Right? Angle S, angle T. Angle S, I know the cosine is 15 over 17. And I know that for sine, for T, the sine is negative 24 over 25. Can I find the third side? You should try that. Go for it. Okay, what do we get for the third side on S? Why negative? Isn't that a Pythagorean triple?
Yes.
ACT feminine. And what about the other? Is that a Pythagorean triple? ACT feminine. We are going to do an ACT practice test in here in the next week, in the next, something like that. It won't go on this 10 weeks, but it will go on next 10 weeks. I'm going to ask this. What
They're going to be out of 100 points too.
It'll be out of whatever we make the target. So if you've got to get 45 right or 50 right, then that'll be how much it's out of. I need to check with the slow and see where y'all ended. I'll probably leave it where y'all ended at. I probably won't up it. Yeah, but you've been in here. You learned some tricks.
But we forgot nothing.
You're right.
I know I forgot.
But it won't be 100 points. It'll be whatever it's. Like if I make it out 45, it'll be out 45.
Bonus points?
If you got over the target, you can get up to 5 bonus points. Whatever that. So if you get 50 out of 45, 55. Okay, what is the cosine of S? What is the cosine of T? Cosine.
7 over 25.
And then what is the sine of S? And what is the sine of T?
Negative 24 over 25.
Not very often do I make you multiply out bigger numbers like that, but every now and again you'll have to do this on the non-calculator part. And I just want to make sure you know how to do that. If you didn't know how to multiply 25 by 17, I know you know how to do that, right? Without a calculator? Do it. Whatever you want. Do you know the non-lattice method?
Yeah.
Let me show you. 25 times 17. So you do 7 times 25. Right? So 7 times 5, which is 35.
Wait, what's the other method?
14.
Okay, cool.
17.
I know
And
that.
then you do 25 times 10, really. You get and then you add those up.
The box.
No, that's you can do that. To us. You can do it. Did you see how it is?
Yeah, I didn't realize.
So you do 7 times 25, and then you do the 10 times 25. Then you add 30. Okay, Okay. 15 times 7. 105. And 8 times 24. 392.
192.
192. Sound good?
Yeah.
Add those up, and I get 297.
425. Whatever that is.
No, I don't think that's
No. It doesn't. Thank
two.
you. That's a bigger number, right?
Yeah, it would have to be a tough one. If it were non-calculator, I'd take it. Now, if they were both divisible by 5, it would, but. Well, it definitely has to be even. It has to be divisible by 2 to be divisible.
3 doesn't work, 4 doesn't.
Okay, we'll do that one another day. That one another day.
Divisibility rule for Saturday.
I know. Okay, one more thing I want to show you before we're done. If you're ever asked this question, this is a co-function identity question. Cosecant and secant are equal when the angles are complementary, right? So what would this angle be if they're equal? How'd you get that?
90 minus 600.
Right? So, if you see those on homework, I figured I could teach you that. Complementary angles for cofunction identity. Alright, this is your homework. I'm going to hand you a worksheet. It is all Tuesday. Monday we'll have a couple more examples, mainly a tangent one. I just want to show you a tangent one. This is only one worksheet. It was supposed to be front back and it didn't happen, so it's in 2 pages. I'll pass around the stapler also. But it's really just one worksheet. It's just 2 pages. I'm just going to start them here at Austin and pass them that way. So just grab one and pass them around. For this quiz, I am going to let you use your trig helper. I won't on the real test, but for today, just in case you've forgotten an identity or something, I'm just going to let you use your trig helper on this quiz. I'm going to pass these quizzes out. You work on getting everything lit up for a trig helper.
Everything. Yeah, I end up now I look back at it, I just find out that's how it works.
Okay, everything off of your desk except your trig helper.
That's all it is.
Yeah, and it does have 2 pages too, so if you haven't got your
I got mine. There, another.
You may not need it back. Okay. Let me make sure. You may start. I think. There are different versions out, so always aware. anything you can think to show